Hello everyone, here is an investigation for finding an approximation for pi. Now I began this with you the other day where I had my inscribed polygon and I was having some difficulty getting those dots to be of a suitable size. So I was able to work that out eventually, and now I've got this situation where I can just change the number of sides of my inside polygon and outside polygon. So the perimeter of the inside one should be a bit less than the perimeter of the circle, should be a bit less than the perimeter of the outside polygon. Divide everything through by the diameter, gives me an approximation for pi. So we can see here at 6 sides, pi falls between 3 and 3.46. Increasing the sides gives us a closer and closer approximation to pi. Not a bad little investigation to do. And we can see here, by changing the radius, the approximation won't change, just the values that lead to the calculation change. And that's to be expected. So let's go back and see how I built this. So this is where I was the other day. I've got those points fixed up. Now I'm going to put an outside polygon. But before I do, I'm just going to show you that line there. That's a vitally important line. I struggle, maybe because I'm a bit of a Dumbo at times, but until I put that line in, I really struggle with things. So I'll come back to that in just a moment. So there's my my inside polygon. Let's put the outside polygon. Start with a ray. Like that. Now I'm going to do a perpendicular bisector. So it will perpendicular bisect that line that I just showed you. So that's good. Now I'm going to find that point of intersection here. So now if I put a perpendicular line through that point, perpendicular to that line, it'll cut the ray and the x-axis, and there's my outside polygon. So perpendicular to that line, through that point, I now need an intersection here and here. Obviously very straightforward. Now, let's just start removing a few things. Get rid of my ray, get rid of a couple of these lines. Now, well, that wasn't what I wanted. Back in. I'll leave the points there for now, it doesn't really matter. The whole up there is the construction. So put this interval in. Everything's reappeared on me. Right, so I'll go put this interval from there. Open my eyes a little bit better, click on the points appropriately. Sensational. Now that ray is essential. Just let you know some of the struggles that I have. Like I said, I'm a bit of a Dumbo at times. I looked online to try and find a general formula for the perimeter of an n-sided polygon, inscribed and circumscribed. Couldn't find a thing. Don't know if it's because I'm bad with search engines. Don't know if it's because it's just not out there anywhere. But I couldn't find it. Then I sat down with pen and paper and worked out my own generalized formula, which is surprisingly easy to do. It's a great little activity I reckon you could do with your trigonometry classes. And then it dawned on me, if I put this ray in, it tells me the length of this interval in, it tells me the length of that particular interval. So it tells me here, it's 1.1547. So if I times it by 6, I've got the perimeter of the outside. Or if I times it by 100, I've got the perimeter of the outside. That made a big difference when it finally dawned on me. So if you feel that there's some simple little things that you're missing, don't feel too bad. I've just confessed my faults before everybody. So put the outside polygon in. And then of course you can go and adjust that for color, opacity, etc. Now if you go back here to the dynamic text, So we just need some sort of calculation. That's very straightforward. Obviously the perimeter of the inside, there's the 6, diameter, that's obviously easily worked out. And then I've got my, you can see here, I've called it, when you go through my file, if you want to look through it, I've called LOWV, that's the lower value. So that's the perimeter of the inside polygon, and then you'll see here somewhere is also UPV, upper value. So these particular values here, when you go through my algebra, you'll be able to work out what I've talked about in each of those particular ones. Okay, I hope you like that file. Hope it's useful. There might be some ideas that you've got there. And I hope you enjoy using that with your class at some stage.